everyone. This is Vijayalakshmi Subnandi from WinMaths YouTube channel. WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation for KCET as well as JEE. Okay. Now, in this session, have to discuss the KCET questions chapter wise for PYQs. Okay. That is mainly this video containing previous year questions on a sets. Okay. Before that, we have to discuss the some synopsis. Okay. First, set. Okay. Set is a well-defined collection of distinct objects. As we know, well-defined. Okay. As we know, well-defined means universally true. Okay. Everyone, whatever it is, doesn't change and everyone will be always. Then in that there is a collection of distinct objects. Okay. So have to collect a distinct objects. Then we can call it as a set is a well-defined collection of a distinct objects. For example, that is set of natural number. Okay. Set of natural number while considering it is a well defined because the elements of the sets 1, 2, 3, 4, 5 up to so on for infinity. Okay. That is a well defined collection of a distinct objects. That is set of natural number, set of rational number, set of irrational number. Not only a number system, it also containing some of the different examples. Okay. Then we can take the number of chapters, the set of all chapters for first PUC. Okay. There are 14 chapters are there. Okay. So we have to make a collection. All chapters will be distinct. That's why the set of all chapters for first PUC mathematics. Next, second one, methods. Okay. So there are basically two methods for representing the sets. Okay. So one is roster form. Simply have to remember roster. That means make a list. Okay. Roster form means have to make a list. What is the list? Okay. So in which containing make a list means object list. Okay. Have to make the objects list. The elements are separated by the commas and are enclosed within the bricks. It means we can call it as a roster form or as another one is tabular form. Okay. Another one is tabular form. That's why have to make a list. Okay. So that list can be represented within the close bracket. That is brace. Simply we can take it as a brace. Then we have to take a distinct object. In between the distinct object have to make a comma. Okay. In between the elements are separated by the commas. Simply roster form means have to make a list of an object within the closed bracket. The elements are separated by the commas. Okay. So another method for remembering the roster form or else tabular form or the both are same. Okay. While considering the example. Okay. So while considering the example, the set of natural numbers 1, 2, 3, 4 up to so on. Then 2, 3, 4, 5 up to so on. Okay. Then collection of the numbers. Again, another one method is set builder form. Okay. Set builder form means have to make a builder. Okay. Have to make a rule for elements. Okay. Have to make a one simple rule for expressing all the elements in the sets. Okay. We can take an as a the elements are represented by using a variable x. Okay. So the simple rule can be taken as a, so all object can be taken as a simply x, that is a variable x followed by a, and after there is a semicolon followed by a semicolon, we have to write the characteristics property possessed by the elements. Okay, that is the characteristics or the rule or the relation of the all the elements are written. Okay, so simply for set builder form, that is make a simple rule, or we can express all the elements within the statements. Okay, or else have to write in the format, that is x be a variable, and that variable can be written in the form of rule within the fuse bracket. So this is the set builder form. Simply, I will take for example for first point, that is make a rule or statement. Simply, that is set of natural numbers. Okay, this is also a rule again. So like this one, this is also one of the representation x such that x be a natural number. Okay, so we can write the set in like this also, or make the statement are written within the clause. Okay, by common rule. Okay, so all the elements can be represented by the common rule, that is called a set builder form. Then make a list or write all the elements within the closed bracket separated by the comma, then we can count it as a roster form. Okay, these two methods are important. Next, later we can consider the types. Okay, so there are some types are they based on expressing the elements. Okay, first one is empty set. As the name indicates, empty. Okay, empty means that is nothing. Okay, so empty set means the set does not contain any element. Okay, a set having no element or does not contain any element, then we can call it as a empty set. So another words for representing empty set, that is null set or void set. Okay, both are the synonyms of empty sets. Null set, void set, or empty set. Usually the empty set can be represented by the empty braces or the symbol null. Okay, these are two representing empty sets. Example for empty set, that is set of natural numbers, set of natural numbers between 1 and, okay, set of natural number between 1 and 2, or else we can write this one as a x be an element, then x is a natural number, that is the element x is lies between 1 and, okay, the element is lies between 1 and 2, then we can call it as a empty set because there is no natural numbers lies between 1 and 2. Next, second one, that is singleton set. Okay, singleton set. How can we represent a single set or taken single set? That is single. The word indicates single means there is a only one element which is present in a set. Okay, that is a set having exactly single element. Then we can call it as a singleton set. So example, set of even prime number. Okay, set of even prime number. So what are the elements of even prime numbers? That is only a 2 is the even prime number. Okay, in that prime number 2 is the only one element as a even prime. Okay, this is the example for singleton set. Next, finite set. Okay, finite means simply limited elements. Okay, limited elements or else we have to count. Okay, limited elements or another simple word for count. The objects are easily we have to count. Okay, so or another one word I can take, that is definition. An empty set or a non-empty set containing definite number of elements. Usually empty set is the one set which is present as a finite set. Okay, finite set means there is no element in the empty sets, that's why we can call it as a empty set. Okay, then uh, empty set is also one of the finite set, and finite set having the definite number of elements. Element should be calculated or element should be counted. Then example. Okay. While considering the example for finite set, that is set of all students. Set of all students in 11th class. Okay. Set of all students in a 11th class. In a particular school. Okay, in our school we can easily count or we can take the number of all the elements or all the students. Okay, we can easily consider, that's why set of all students in 11th class of our school. Okay, so of our school, this is the finance. Okay, next, infinite set. Okay, infinite means unlimited elements. Okay, that is infinite means there is an infinite number of elements. A set which contain infinite number of elements, then we can call it as a infinite set. For example, that is all number sets, sets of natural number. Okay, sets of natural number start from 1, 2, 3. But the last term, we don't know. That's why we have to take a infinity. Set of rational numbers, set of prime numbers and all. Okay. So, or example, the set of all points on a line segment. Okay. Next, equal sets. Okay. Next one is equal sets. How can we take a equal sets? For example, while considering the two set. Okay. So we have to take a two sets, set A and set B. Okay. So when we say both A and B are equal sets, means both sets having the same number of elements. First condition for equal sets is both sets having the same number of elements. Then the element should be identical. Okay, the element should be identical irrespective of. The element should be identical irrespective of arrangement. Okay. For example, while considering the equal set. So set A containing the numbers 1, 2, 3 and set B, that is 2, 1, 3. Okay. Here both A and B having the same number of elements is exactly same. 1, 2, 3. There are 3 elements. Then set B having a 2, 1, 3. There are 3 elements. Then 1 is same. Here also same. 2 is same. Then 2 is also present. 3. Yes. Both set having the same number of elements. First condition. Then the elements are identical irrespective of the arrangement. Okay, then we can call it as a equal sets. Then next concept will be subsets. Okay, so before that subset, first have to consider the two sets. Okay, so A and B are the two set. Okay, A and B are the two sets here. A is subset of B means B is the main set. Okay, B is the main set. B is the main set. By using the elements, we can make another one set that call as A. Okay, so B is the main set. By using the elements of the set B, we have to take we have to make another one set called A. Then A is said to be a subset of B. Okay, so if A, it may containing all the elements of B. Okay, that is for any two sets A and B, A is said to be a subset of B. That means if every element of A which is also an element of B. ಇದ್ರೊಳಗಿರುವಂತ okay, all the elements which is present in A is present in B also. Okay, that's why A is said to be a subset of B. So indirectly B is the largest set or else B is equal to A. Okay, so there are some results are for subset. When you take A union B, okay, if A union B is equal to B, when A having the largest number of elements compared to A, or else A union B is equal to A, it means A having the exactly same elements of B, or A having the more elements other than A. Here A union B is equal to B means B set having the more elements or exactly same to the A. Okay. Next concept, that is proper set. Okay. Proper set means one of the elements. Okay. One of the element which is less than the main set. Okay. For example, while considering the two sets A and B. Okay, B is the greatest or B is a set. Then we can make another one set as A having the exactly same elements other than one element. Okay, so we can call it as a proper set. So usually proper set can be represented as 2 to the power n minus 1. Exactly. So which is lesser than the one of the element or less than the itself. Okay, then we can call it as a proper set. Then next, power set. Okay, so important concept, that is power set. Power set means set of all the subsets. Okay, power set means set of all subsets. Then we can call it as a power set. Usually power set can be represented as a 2 to the power n. Okay, 2 to the power n. The calculation for finding the subsets, that is 2 to the power n. It means if a set containing one elements. So usually n represents the number of elements. If a set containing only one elements, then how many number of subsets are there? To the power 1, that is 2. So the subsets are the 2. For example, A is a set containing the element 1. Then how many subsets are there? That is a set having two subsets. One is set containing 1. Another one is empty set. Okay. So that is the important result is empty set is the subset for every set. Okay. Empty set is the subset for every set. That's why the collection of all the subset, then the power set of A is equal to collection of all the subsets. Okay. For example, our set having a three elements A, B, C. Then how many subsets are there? Usually the number of elements. So number of elements of A can be represented by n of A. That is number of elements of A is 3. So how many subsets are there? That is 2 to the power 3. Then 2 to the power 3 will be 8. There are 8 subsets are there. So subsets of A can be written as First one is the empty set. Okay. So have to write the singleton set, that is set A, set B and set C. Then again have to consider the two elements set AB, set BC and set CA. Then the last one is a set itself is a subset. That's why I have to consider A, B, C. So now count all the subsets 1, 2, 3, 4, 5, 6, 7, 8. Okay. There are 8 subsets for set A containing 3 elements. Okay. Now next, that is intervals. Okay, the intervals is also very important concepts. That is, usually there are two intervals are there. One is close intervals and another one is open. Okay, one is the close interval and another one is open interval. Okay, so while considering the any two elements, okay, that is, let A and B are the two elements which is belongs to the real number. So A and B are the two elements, that is AB belongs to the real number. Then while taking A is less than B, okay, A is less than means A is the smaller element and B is the greater element. Then we can define one by one. Closed means the end points. Okay, these two elements A and B, the all the numbers including A and B, that is called the closed intervals. The end point should be included in that interval. We can take it as a closed intervals. Then open interval means we don't consider the end points. Have to neglect the end points. There is another one called closed and open interval, that is include and exclude. Include and exclude. The endpoint should be included in a closed interval. Here the endpoint does not include, that is excludes. Okay. Now we will take a now. First one. There is a closed interval. Simply, we have to consider the closed interval. The endpoints are including. Okay. So, this is the set representation. X be an element. So, A is less than X less than or is equal to B. So, the element X which is lies between A and B, both the elements are included. So, which is representing as a line. Okay, the endpoints will be included. Okay, have to write the close bracket. Okay, for the close interval, have to write the close bracket. Then, second, this is the open bracket. Usually, open brackets are written like this and close brackets are written like this. So the endpoints are excluded. Okay, the endpoints are excluded. The set representation X such that A is less than X less than B. Then so representation will be like this. Then another based on closed interval and open interval, we have considered the semi-closed or semi-open intervals. Semi-closed. Okay. Here semi-closed means the smaller, wherever there is a less than or equal symbols present. So the end point will be included here. Then it is not included. Okay. Here there is a strictly condition is there. That's why the end point B is not included. Not included. That's why we have to make a open interval. Here the endpoint A will be included. That's why we have to take up this one. Next, semi-open. Here the endpoint A not included and B will be included. Okay. This is the intervals. Universal set contain all the set. Okay. Universal set means it contains all the sets. Now, based on a sets, there are some operations are there. Okay. Based on a sets, we have discussed empty set. There is no elements present. Singleton set, a set containing only one element. Then finite set, it set containing finite number of elements. Infinite set, there is a infinite number of elements. Equal sets, equal number of elements, and all the elements should be identical. Okay. Now, operations on a sets. Okay. So, first one is union. Okay. First one is union. A union B. Okay. So, this can be written in a set form. That is A union B is equal to X, such that X belongs to A or X belongs to B. X belongs to A or X belongs to B. It means every element of A and every element of B can be written in a one set. Okay. All the elements should be written within the closed bracket if both sets having common elements have to write once. Okay. All the elements should be written within a closed bracket, but if the elements are repeated, then we have to write only once. Then we can call it as a union. That's why X belongs to A or X belongs to B. While considering the example, A containing 1, 2, 3 and B containing 2, 3, 4. Okay. 1, 2, 3, 2, 3, 4. Then A union B is equal to all the elements of A. First have to write all the elements of A. If all the elements of B, okay, 2, 3, 4. Then 2, 3 already written. Then have to write the 4. If both sets having the identical elements have to write only once, then we can call it as a union. Okay. Then second one, intersection. Okay. Intersection means usually we can take it as a X, an element. X belongs to A and the word can be represented as a and. And means the set which the element which containing both set. Okay. An element which is present in a both set, then we can call it as a intersection. That is the common element between these two sets. 1, 2, 3. Same. Set B is equal to 2, 3, 4. So what are the common elements between these two sets? That is 2, 3, 2, 3. Therefore, A intersection B is equal to 2. Okay. There is a common elements between A and B. Then we can call it as a intersection. Again, complement. Okay. Here there is a complement means first have to consider one universal set. Okay. Have to consider one universal set. Based on the universal set, we have to write the complement. That is the element which is not present in A, then we can call it as a complement. Okay. Complement means an element which is not in A, then it is called a complement. For example, by considering the universal set, that is U is equal to 1, 2, 3. Then A is equal to 2, 3. Then what is the complement? So the element which is not present in A. So 2, 3 already present. So the element which is not present in A is 1. That's why A complement is equal to. Okay. Now the another one is difference of sets. Okay. That is difference of sets. What do you mean by the difference? Okay. Difference means an element X Okay, an element X which is present in A but not in B. Okay, so the element which is present in A only but it will be absent or which is not in B, then we can call it as A minus B. Okay, while considering the example, A is equal to 2, 3, 4 and 5 and B is equal to 3, 5, 6. Okay, so difference A minus B. Okay, A minus B can be taken as the element which is present in A but not in B. First have to neglect the common elements. So 3, 3 will be common. That's why I will neglect the common elements. Later, the element which is present in A is the elements which is present in A. That is 2, 4, 5. A minus B will be 2, 4, 5. Then what about B minus A? B minus A will be the element which is present in B only. That is 5, 6. Okay. So A minus B and B minus A are not equal. A minus B not equal to B minus A. Okay. These two are the unequal sets. A minus B and B minus A are the unequal sets. Okay. So by operations, union, intersection, complement and difference. Okay. So another one is there, that is symmetry. Okay. Another one is there, that is symmetric. We will discuss now. Okay. That is symmetry. That is what, how can we take a symmetry? So the union of symmetric means the union of A minus B and B minus A. Okay. A delta B. The union A delta B or asymmetric B can be taken as the union of A minus B and B minus A are called the symmetric difference. Okay. These are the important operations on a sets. Okay. Now, and we will discuss the some of the laws of operation, some important properties. Okay. So, first one law will be, one is A union A. Okay. So I will take a first one law. First one is A union A. Okay. Both are the same sets. Okay. While considering all the elements, again we get A only. Okay. Then what about the intersection? A intersection A is equal to A only. A union A is equal to A and A intersection. There is a common element between those sets will be same. Okay. Next, second one property, that is A union null set. Okay. So combining null set and union, null set means there is no elements. So A union B, collection of all the elements, we will get A only. Then what about the intersection? A intersection null set will be a null set because there is no common element between these two sets. Then third one, there is a commutative property, that is A union B is equal to B union A. While exchanging the elements, again we have to arrange in the same manner. A union B is equal to B union A. Here for intersection, A intersection B is equal to B intersection A. Okay. Next, associative law. Then associativity, A union of B union C is equal to A union of B union C. While combining all the elements, again we get the same result. For intersection A union, A intersection B intersection C, then A intersection B intersection C. Both are the same results. Then again important result will be De Morgan's. Okay, these are the very important, that is De Morgan's law. Okay, so there are two laws are there. A union B complement. Based on a complements, there are two simple laws are there. A union B whole complement can be written as, have to separately complements. A complement intersection B complements. While taking U whole complement means there is a individual between the intersection. Then A intersection B complement can be taken as A complement union of B complement. Again another one important. Next, universal complement can be taken as a set other than the universal set, that is A. Sorry, while taking null set. Any of the A set containing the universal will be null set. Okay. Next we consider universal complement will be null set. Then the complement of null set will be again a universal set, vice versa. Now, then A union A complement. Okay, so A means the set containing all the elements. A complements means there is no similar letters or similar object than A, null set. Then what about the A intersection A complement? Sorry, here that is universal set because it including all the elements, that is universal. This is complement because there is no elements between the complements, that why it is null set. So last property, A complement of whole complement. Okay, A complement of whole complement is again a A set. These are the very important law of operations on a sets. Then some of the formulas based on the number of elements. Okay, this is the last concept. For any two finite sets A and B, we have the number of elements should be number of elements of A union B is equal to number of elements A plus number of elements B minus of number of elements A intersection B. Okay, if A intersection B should be a non-negatives, then number of elements A union B is equal to n of A plus n of B. If there is a n intersection B, means there is no common element between the two sets. Then based on one rule, symmetric, that is n of A symmetric B is equal to n of A plus n of B minus 2 into n of A intersection B. Then based on a difference on sets, n of A minus B is equal to n of A minus n of A intersection B. Then there is a first question which is from 2005. Okay, so first question is, if A is equal to x such that x is an integer and x square minus 9 is equal to 0. So B is equal to x, x is a natural number and 2 is less than x less than 5. Then C is a set, x is a prime number less than 4. So while solving these questions, have to write the sets, the elements first. Okay, so have to reduce this set builder form into tabular form. So have to write all the elements. X square minus 9 is equal to 0. Okay, While solving the equation, x square minus 9 is equal to 0. So x square is equal to, take minus 9 on the right side, it becomes plus 9. Then x is equal to plus or minus 3. So what are the elements for a is minus 3 and plus 3. I have to write here the set having the elements minus 3 and plus 3. Then what about the set B? Okay, x is a natural number and the number which is lies between 2 and 5. Okay, what are the elements between 2 and 5? Here the end point should be included. 2 is included. So the number will be 2, 3, 4. But 5, there is a strictly condition. So 5 is not included. So the number of elements are 3. That is 2, 3, 4. Then C. X is a prime number less than 4. What are the prime numbers less than 4? That is 2 and 3. These are the elements of set A, B, C. Now our actual question is B minus C union of A. First have to write the B minus C. B minus C means the element which is present only B. Okay. So while writing the B minus C, first have to cancel or neglect the common elements between two sets. What are those? 2, 3. Here also neglect the common elements 2, 3. So the element which is present in B is 4. Then there is a union minus 3, comma. Okay. Union means set of all the elements which is present in both the sets. If any of the element will be repeated, then have to write once. So arrange the numbers in a ascending order. First 3, 3, 4. So B minus C union of A is equal to minus 3, 3, 4. The option number D is the right answer. Okay. Now, there is a second question. A and B are the two sets having 3 and 6 elements respectively. Okay. So, there are two sets having 3 and 6 elements. So, first I have to write number of elements in A is equal to 3 and number of elements in B is equal to 6. Later, they given two statements. Okay. Minimum number of elements in A union B is 3. While making A union B, A union B means the set of all the elements which is present in A and B. Okay. So A union B must and should equal to A or it is equal to B. Okay. A union B must and should, the number of elements should be equal to A or equal to B, less than 3. Okay. Here the maximum number will be 6. So n of A union B maximum. Okay. Minimum 3 elements are there, or maximum how many elements? N of A containing 6 elements. A union B means must and should it containing maximum 6 elements. Okay. Then in the option minimum number of elements A union B is 3. So this is the false statement because maximum it may 6. Both the sets having distinct elements, then A union B should be 6. Okay. The maximum number of elements in A intersection B. So in between these two sets, A intersection B is 3. Okay. So there are maximum will be how many number of elements are there? There is a 6 elements. Okay. Maximum number of elements in A is A intersection B. That is 3. Correct. This one is the correct because So both sets having the same number of elements. So n of A is having 3, then n of B is 6. This is the intersection. Means, so common elements between these two sets will be 3. So second statement will be right. Then first statement will be wrong. Okay. Then option number is the right answer. Statement 1 is false. Statement 2 is true. Third question. Two finite sets have a m and n elements respectively. Total number of subsets of the first set is 56 more than the second set. Okay. Then have to find the values of m and n. Okay. Here first have to consider the two finite set as a and b. A be a finite set, then B is another one set. So two finite set having a m and n elements. So n of A is equal to m elements, n of B, the set B having the n elements respectively. Okay. Then again, second statement is total number of subset of the first set. While considering as a first set is 56 more than the second set. So I can write it as a n of A is equal to n of B more than the second set means have to add the 56. Okay, more than the first set. Then n of A is equal to n of B plus 56. Here they given a subset, number of subset. Then if n of A having a m number of elements, then what about the subsets? That is 2 to the power m. So usually the calculation for the number of sets will be using power set, that is 2 to the power n. Here the elements are m, that's why I will take a m is equal to 2 to the power n, because the set B containing how many elements? N elements plus 56. Now calculating the m and n values. Now I will take 2 to the power n here. 2 to the power m minus 2 to the power n is equal to 56. Again, I will take the common. Okay. Now I will take the common n, because n is the smaller number. That's because n of A. So set A having the large number, then set of B is small number. That's why I will take 2 to the power n will be common. Then 2 to the power m minus n. While taking the common, here there is no n. That's why 2 to the power m minus 1 minus 1. 2 to the power n taking as a common, then remaining will be 1 is equal to 56. Then all the results are should be in the power of 2, because we have taken base as a 2. That's why take 56 as a fractions of 2. So 56 can be written as 2. 2 to the 4, remaining 6, that is 28. Then 2 1s are 2 4s are, again 2 1s are, that is 2 7s are 7 and 1. So the number can be written as 56 can be expressed in terms of n, sorry 2, that is 2 to the power m minus n minus 1 is equal to 2 to the power 3 into 7. Okay. Here 2 can be written as 2 to the power 3 and 7. Again comparing the right side and left side. Now 2 to the power n. Here also 2 to the power 3 are there. If bases are same, then power should be equal. So I will take 2 to the power n is equal to 2 to the power 3. And another one result, 2 to the power m minus n minus 1 is equal to 7. Here comparing the result, the n value becomes 3. So substitute n value here, 2 to the power m, n will be 3. Now consider minus 1 on this side. It becomes plus 7 plus 1 is 8. Again 8 can be written in terms of 2. Yes, definitely that is 2 to the power 3 minus 4. Sorry, m minus m minus 3 is equal to 8 can be written as 2 to the power 3. 2 to the power m is equal to, if powers are same, sorry, bases are same, power should be added. Now, that's why directly I am taking m minus 3 is equal to 3. I want the value m. So, m should be, take minus 3 on this side, it becomes 6. 3 plus 3, 6. So, m is 6, n will be 3. The values of m and n. First have to write the value of m, later have to write the value of n. So in that option, first they given 6 m value, n as second value. That is option number 3 is the right answer. Okay. Now let's move on the next question. Which one of the following is an empty set? Which of the following is an empty set? They given in a set builder form. So first have to write in the tabular form. X square minus 9 is equal to 0. Okay, so while solving, x square minus 9 is equal to 0. So x square is equal to plus 9. X is equal to plus or minus 3. So the elements of x should be real numbers. That's why we have to consider the both the elements minus 3 comma 3, which is not a empty set. Now again, second equation, consider x square minus 1 is equal to 0. While solving, x square is equal to 1. X should be plus or minus 1, which is also not a empty set because this set contains minus 1 plus 1. Next option, x square is equal to x plus 2. Okay, then x square minus x minus 2 is equal to 0. While solving this equation, we get a two numbers. Okay, so sum of any two number will be minus. Then while multiplication, we will get a minus 2. That is 2 into 1. Okay, 2 ones are 2. 2 minus 1 will be 1. That's why it can be taken x square minus 2x plus 1 minus 2 is equal to 0. That is minus 1x. While comparing the result, we get x minus 2 plus, here take common 1, then x minus 2. While solving the equation, while taking x as a common, x minus 2 plus 1 as a common. X minus 2 is equal to 0, x plus 1 is equal to 0. The value of x will be minus 2 and minus 1. Here plus 2, minus 2, 1, which is also not a empty set. So indirectly the option number D is the correct. But once while checking the option, x square plus 1 is equal to 0. While solving the equation, x square is equal to, take minus 1 on this side, it becomes plus 1 on right side, it becomes minus 1. X square is equal to minus 1. Then what about the x value? X is equal to, okay, here x is equal to square root of minus 1. It is the value of I. Here x is a real number, but I value is not a real number. This is complex number. There is no elements present in that set. That's why it is not an option. So the answer is 4. Question number 1. Okay. If A is a set containing 1, 2, 3 up to so on 10. Okay. Find the number of subsets of A containing only odd numbers. Okay. Here first have to check the odd numbers. Okay. So in that, how many odd numbers are there? From 1 to 10. What are the odd numbers? I will take another one set as a B. That is a set of all odd numbers. Find the number of subsets of A containing only odd numbers. So the odd numbers will be 1, 3, 5, 7, 9. Okay. The number of odd numbers will be 1, 3, 5, 7, 9. Okay. Here, after that finding the odd numbers, have to find the subset. So there are how many odd numbers are? There are 5 odd numbers. So 2 to the power 5 will be how much? That is 2 into 2 into 2 into 2 into 2. 5 times. 2 2 is 4, 4 2 is 8, 8 2 is 16, 16 2 is 32. But, okay, so in that there is a one empty set is there. Okay, so every set containing a one empty set. So here also the empty set will be included, but in that empty sets there is no odd numbers. Okay, that's why have to remove the odd numbers. That is 2 to the power 5 minus 1. That is 32 minus 1. Then we get the set of these subsets which containing only odd number is 31. Okay, the option number is the right answer. Question number 6. Write the set builder form. Okay, how to write the set builder form? So x is first option. X is an integer. Integer means it containing there is no limits. So from minus infinity to plus infinity, there are so many integers are there. Okay, so 0 plus or plus or minus 1 plus or minus 2 up to so on. So this is not represents the first option. Second, x is the root of equation x square plus 1 is equal to 0. Just we already study now. Okay, so x square plus 1 is equal to 0. Then x square should be minus 1. It is complex number. So this is also not a set builder form. X is a real number, not because these two numbers are the integers. So the option number B is the correct answer because the roots of equation x square is equal to 1. X square is equal to 1 means x is equal to plus or minus 1. So the option number D is the right answer. Question number 7. Okay. The set A is equal to x such that modulus of 2x plus 3 less than 7 is equal to which interval? Okay. Whenever the number can be expressed modulus function in terms of interval. Okay. Whenever the sets or any object can be expressed in terms of intervals. So the modulus function can be written as a on left side take minus 7. Okay, strictly condition. That's why have to maintain here minus 7 is less than remove the modulus function 2x plus 3 less than 7. Okay, now have to find the value x here. Okay, so first simply solve this one. Take plus 3 on both sides. Minus 7. When taking left side, it becomes minus 3. 2x. Take plus 3 on this side, it becomes minus 7 minus 3. Minus 7 minus 3, it becomes minus 10. Less than 2x. Less than 4. Okay. Again, have to solve for the x. Okay. Divide whole equation by 2. We will get minus 5x less than 5 less than x less than 2. So check the option whether the answer is given. Okay, here in that there is no option here for x. Okay, so neglect these two options. Again for 2x there is no option present, so the option number 4 is also neglected. Okay, now x plus 5. So have to for our confirmation have to add whole equation by 5. Minus 5 plus 5 less than x plus 5 less than 2 plus 5. Okay. Add 5 to whole equation. Then we will get minus 5 plus 5 will be 0. Then x plus 5 less than 2 plus 7. 5 it becomes 7. So there is an option. Yes. The option number is the correct. Okay. As we know already, the options are given. But actual, for our confirmation, I showed the another one step. Better to neglect options in that time. Okay. So have to practice more and more. Sets is a simple concept. So based on the set, the questions also very simple. Okay. So don't lose your marks because 1 marks is also very important for your rank. Okay. From 1 marks, you will get the better ranking in the CET. Okay. Then it helps for getting a good good seat for in good college. Okay. Thank you. If you really like my classes, please go subscribe my channel, that is WinMaths by Vijay Lakshmi. I will upload chapter wise questions one by one with the previous year questions. Okay. I will discuss more and more questions on KCET level as well as JEE questions. Please share my channel to your friends and make a subscribe and also support me. If any doubts or any clarification, please put your messages on comment. Okay, I will take your comment.